All right, today we're jumping into one of the most famous and, let's be honest, one of the weirdest ideas in all of science, Schrödinger's cat. For almost 100 years, this thought experiment has been this ghost that haunts physics, mainly because it leads to a conclusion that just seems to fly in the face of common sense. So let's just get right to the heart of it. The whole paradox forces us to ask this absolutely wild question. If you take the rules of quantum mechanics literally, a cat inside a box, its fate tied to some random atomic event, could exist in a state of being simultaneously alive and dead, at least until you open the box to check. I mean, how can that possibly be real? And you've got to understand, this isn't just some brain teaser. It's a fundamental clash in our understanding of the universe. The very rules that work perfectly to describe the tiny world of atoms and particles, the quantum world, well, they seem to churn out completely absurd results when you try to apply them to the world we actually live in. You know, the world of cats in boxes. So to really wrap our heads around this, we need to focus on this central conflict. It's almost like the universe is running on two totally different operating systems. One for all the teeny tiny stuff, and a completely different one for everything big. And this is where it all kind of falls apart, right? Down in the quantum realm, an atom can be in what's called a superposition. It can be spinning clockwise and counterclockwise at the exact same time. But in our world, a cat is either alive or it's dead. It's not both. So what's going on? Why does that quantum rule just suddenly seem to break when things get bigger? But what if the problem isn't the cat? What if the problem is our fundamental understanding of reality itself? Well, there's a new approach called vacuum field theory, or VFT for short, and it offers a pretty radical new answer. It suggests that maybe superposition isn't just a mathematical trick. Maybe it's a real, physical thing. Whoa, okay, don't worry about the math here. That's not the point. The big idea behind VFT is that the vacuum of space isn't actually empty. It's a real, physical field. Think of it like a fabric of reality. And just like any fabric, it can be warped and stretched, and it can have different properties in different places. And here's the absolute game changer. VFT says that superposition is a real but very fragile physical state of this fabric of reality. And crucially, this state has a physical size limit. It can be broken. This completely reframes the whole problem. So, how in the world does this fix the cat problem? Well, it all comes down to one single, really elegant concept: the coherence limit. This is the idea that finally builds a bridge between the weird quantum world and our everyday reality. So the theory suggests that this quantumness, this state of superposition, can only stretch so far. It has a maximum physical length. A great way to think about it is like the surface tension on water. It's strong enough to hold up a tiny little insect, but a big rock? Yeah, that's going to break right through. And boom, there's your answer. A tiny atom is just like that insect on the water. It's way smaller than the coherence length, so it has no problem maintaining its quantum superposition. But a cat? A cat is the rock. It's a massive system, just far too large for the vacuum's coherence to support. The moment you even try to put something as big as a cat into superposition, the physical fabric of reality just snaps. I mean, the source material puts it pretty bluntly. That state of being alive and dead isn't just weird or counterintuitive. According to this theory, it's physically impossible. The system is simply too big to sustain that delicate quantum state. Now, this leads to another huge, and I mean huge, implication. In the classic telling of the story, it's the act of observation, someone peeking in the box, that forces the cat to be either alive or dead. But VFT says, nope, you don't need a conscious observer at all. The universe doesn't need us to make up its mind. Physics takes care of it all by itself. So let's just put this side by side with the other big ideas out there. The classic Copenhagen interpretation says you need an observer to collapse the possibilities. The many worlds idea gets around that by saying the universe just splits into two different realities. VFT offers a clean third way. The collapse is a real physical process. It happens automatically because the system gets too big. No observer needed, no branching universes. So let's just walk through the whole thing from VFT's point of view. The tiny little radioactive atom that kicks everything off? Sure, it's in a superposition. But the second it interacts with the huge system of the cat, that delicate quantum coherence is instantly shattered by the sheer scale of it all. The system is physically forced to pick a lane, alive or dead, long before anyone even thinks about opening that box. Okay, but here's what makes this so much more than just a cool story. This is actual science. Because unlike some of the other interpretations, VFT makes real, concrete predictions that we can actually test out in the real world. So what are we actually looking for? Well, VFT predicts that there's a measurable size somewhere between an atom and a cat where quantum weirdness just stops working. It says we should be able to actually detect the physical process of this collapse happening on its own. These are things we can genuinely look for in a lab, which could prove or maybe even disprove the whole theory. And that kind of leaves us with this final lingering thought. For so long, Schrödinger's cat has felt like this deep philosophical mystery, a paradox about knowledge and observation. But what if it was never a paradox to begin with? What if it was just a giant signpost, pointing all along toward a deeper physical rule about the very fabric of reality that we're only just now beginning to find?